Before we have a look at the next example, we're going to have a look at, in a little bit more detail, at arguments of complex numbers. So far we've seen that if we've got a complex number, say z equals 2 plus 2i, then the argument of the complex number is the angle between the positive real axis and the position vector of the point. So in this case it would be positive pi over 4 because we've moved in the positive direction, the anti-clockwise direction. Remember, this is the anti-clockwise positive direction. So we could say here that the argument of z is equal to positive pi over 4. Let's look at a slightly more complicated situation. Let's say we've got a complex number z1, which is 4 plus 2i, and another complex number, which is 6 plus 4i. And what we're going to be interested in is the argument of these two complex numbers subtracted. Let's do the argument of z2 minus z1. So we're going to look at two different ways of thinking about this, but one way that's going to be useful is to think about this as a vector. So z2 minus z1 is the vector that takes us from the point z1 to z2. So it's this pink vector here, and it's going in that direction there. So we've got to be a little bit careful though, because what we really mean by this pink vector is it's actually a complex number. z2 minus z1, if you work that out, is actually 2 plus 2i. And that's reflected in the fact that this vector goes right by 2 and up by 2. So what we're really thinking about is z2 minus z1 is the vector 2, 2. And I'm going to put that in quotations there because it's obviously not a vector. Okay, we're abusing notation there. So we're basically working out what's the modulus of 2 plus 2, the argument of 2 plus 2i. So if we plot this coordinate 2 plus 2i, this point, we're saying what's the argument of 2 plus 2i? Well, you can see that that vector, the position vector of 2 plus 2i, is going to be exactly the same as this pink vector. We've just moved it down to the origin. And we know that the argument of that pink vector here, 2 plus 2i, is going to be that angle there, which we know is pi over 4. So you can think about this as the argument of one complex number minus the other complex number is going to be the angle that the vector makes with the positive real direction, so the positive direction to the right. So we could have just said, well, that angle is pi over 4, so that's the argument of z2 minus z1. So let's just check that we understand what we've just done. So I know we could work out, we could simplify what's inside the bracket, but let's think about this as the argument of one complex number minus another complex number. So let's sketch this in the Argand diagram. So we've got one point which is 4 plus root 3i. So that's our point z1. And we've got another point which is at 3. So z2 is equal to 3. And that's z2. So you can think about this as this is the vector that takes us from 3 to 4 plus root 3i. Takes us from z2 to z1. And we're going in that direction there. So this is basically saying what's the argument of this vector. What we really mean is we're saying what's the argument of this complex number up here, because that would be z1 minus z2. So we're looking for that angle over there. What is that angle there? Let's call that theta. So we know that's side length 1. We can draw a right angle triangle. That's root 3. So we find that theta is pi over 3. So the argument of that is pi over 3. Okay. Let's look at another example. Here we've got the argument of one complex number take away another complex number. So let's sketch these two complex numbers. We've got 2 plus 3i and we've got a point 3 plus 4i. And we could obviously just work this out, simplify this, and say that this is just the argument of minus 1 minus I, and then work out what's the argument of minus 1 minus I. But another way that's going to be useful for the next example of thinking about this is inside the bracket here we've got the vector that takes us from 3 plus 4i to 2 plus 3i. So that vector there, and it's important to realise that this vector is going in this direction here. So we want what's the argument of that vector. Of course, what we're really saying is what's the argument of the complex number minus 1 minus I, which would be that complex number down there. But you can see that these vectors are exactly the same as each other. Well, the argument is going to be what angle does it make with the positive direction, positive horizontal direction. So if we put in a dotted line like that, that's equivalent to saying what is that angle there? And that angle is actually minus 3 pi over 4. And it's minus because we've gone in the negative direction. We've gone clockwise. So that argument there would be minus 3 pi over 4. So that's minus 3 pi over 4.